Welcome to TOneAcademy. In our last session, we started discussing about the LCM and HCF. Okay, where we discussed some of the basic model problems from the concept called LCM and HCF. So today in this session, we are going to see some of the advanced question which was asked in the recent examinations, right? So in our LCM and HCF, we have one of the most common formula. What it is product of two numbers is equal to product of their LCM and HCF. Product of two numbers is equal to the product of their LCM and HCF. Now see here students, we need to understand one major basic thing under this LCM and HCF concept is which is related to our ratios. While we discussing the ratios, we will discuss in depth about that. But meanwhile, we should understand some of the important things while discussing this LCM and HCF. What it is, for example, I have two numbers. Take example 30 and 40. If I want to express this 30 and 40 in terms of ratio, usually what we are going to do, we are going to cancel it with 10, right? So 10 threes and 10 fours. So we are going to cancel it with 10 and we are going to write it as 3:4. So this is the least simplified form, right? We cannot further cancel this. Now, what is this 10? What is this 10 means? Without knowing to us, whenever we express two numbers in the form of ratio, we always cancel them with their HCF. That means 10 is the HCF of 30 and 40. So whenever you want to write two numbers in the form of ratio, usually you cancel them with their HCF. And the output resultant will be there, right? And this resultant will be always co-primes. Okay, so 3 and 4. Here the output is 3 and 4. So 3 and 4 are co-primes. That is the reason we cannot further cancel them. So here this 10 is the HCF. So when you want to restore a ratio into the number, vice versa, right? Actually, I have written 30 and 40 as 3:4. Now, if I want to restore it to the original number, what I need to do? I need to multiply with the same 10, right? Then it becomes what? 30 and 40. Okay, so this is the basic understanding which we need to observe while solving the problems of this LCM and HCF. Okay, next, see here, what we can say is, when you write two numbers, for example, if I say that two numbers are in the ratio of 5:6, then what you can write? You can write that as 5a and 6a, right? Usually we do in this manner. So what about this a? If you observe this a is nothing but the HCF of these two numbers. That is the thing, right? See here 3:4. To restore it with what I multiplied here, usually you can assume it as 3x and 4x, something like this. But you are multiplying it with what? 10. 10 is nothing but the HCF. That means whenever you write two numbers in the form of ratio, you usually cancel them with their HCF. And when we restore a ratio to its original number, we multiply it with the HCF of those two numbers. And after cancelling, the result will be there, right, in the form of ratio. The content in the ratio will be always co-primes to each other, right? So we are going to solve some problems based on this concept only. Now, the first formula in this LCM and HCF is product of two numbers is equal to product of their LCM and HCF. Next, the LCM of two numbers is 280 given and the ratio is 7:8. The two numbers are, yes, just now I told you, right? See, we know that product of two numbers is equal to product of their LCM and HCF. They given us the ratio between the two numbers. What did they given us? 7:8. That means what we are going to assume them as 7x and 8x. We are going to assume the two numbers as 7x and 8x. What is this x? As we discussed just now, it is nothing but the HCF. So here HCF is x. And given that LCM is what? 280. LCM of the two numbers is 280. So product of two numbers is equal to product of their LCM and HCF. That means 7x into 8x is equal to x into 280. So x will get cancelled. 7 ones 7, 40s, 8 ones 8, 5s. So what is the value of x which I got here? 5. This x is nothing but the HCF of the two numbers. That is 5. But what is our question here? Our question is here, what are the two numbers? The two numbers are in the ratio of 7:8, right? So you got x as 5. That means the two numbers are 35 and 40. What I have done here? 7 into 5 and 8 into 5. 7 into 5 and 8 into 5, right? We will see next question. Next question. The LCM of two numbers is 630 and their HCF is 9. Okay, given that LCM of the two numbers is what? 630, good. And the HCF given for us is what? 9, fine. If the sum of two numbers is 153, their difference is, given that the sum of the two numbers has 153, we know that product of two numbers is equal to product of their LCM and HCF. If I assume the two numbers are x and y for time being, so xy becomes what for me? 630 into 9. xy value becomes 630 into 9. And in the same question they given us the sum of the two numbers. What is the sum of two numbers they given for us? X plus y is equal to 153. Sum of the two numbers they given here is 153 and they are asking us to find their difference. That means they are asking us to find x minus y. X minus y. We all know from algebra what it is. X minus y whole square is equal to x plus y whole square minus 4xy. X plus y whole square minus 4xy. So what you will get here? X plus y whole square means 153 whole square minus 4 times of 630 into 9. So you will get x minus y whole square. Where you get here x minus y whole square. Solve for x minus y. You will get the x minus y here. Okay, you get the value of x minus y here, right? Next one. See student, those are small calculations. I don't want to waste your time. So directly, please calculate those things. Next, the LCM of two numbers is 45 times their HCF. Okay, good. Given that LCM is 45 times of the HCF, right? Next, if one of the numbers is 125, okay, they given that one of the numbers is 125, then, and the sum of HCF and LCM is 1150. Okay, given that LCM plus HCF is what? 1150. The other number was. Now see here very clearly they given us the relation between the LCM and HCF. What it is? LCM is 45 times of HCF. So if I take HCF as some x, HCF as some x, what about my LCM? LCM becomes 45x. Given that sum of this LCM and HCF is 1150, so that means when I add these two things, what I get here? 46x is equal to 1150. 46x is equal to 1150. If you observe 23 2's, 23, 5 and zeros, 2 1's, 2 5's. So what is the value of x I got here? 25. X is 25 for us. X is 25 for us. Okay, good. We got the value of HCF. What is HCF now? HCF is 25. Then what happens to my LCM? My LCM is 45 into 25. Why? Because LCM is 45 times of HCF. See students, here no need to find the exact value of LCM. Why? Because that is not our final answer. Don't waste your time by solving what is 45 into 25 and don't waste your time. Okay, we will simply substitute it wherever it is required for us. Given that one of the numbers is 125, right? We know that product of two numbers is equal to product of their LCM and HCF. Fine, we will substitute there. So product of LCM and HCF means what I can write? 45 into 25. This is LCM into HCF is also 25. Okay, into 25, that is equal to, what is the one of the two numbers they given for us is 125 and the other number I will assume it as some A. Now please observe here 25 ones, 25 5's, good. Next 4 ones, 4, 9, 5 ones, 5 9's. Okay, so A value is how much? 9 into 25. Now we need to find the value of A. Why? Because that is the required answer for us. So 925 is what you will get here, 225. So the value of A here is 225. A means nothing but the second number. Okay, so we need to find the answer in this manner. Next one. The least number which should be subtracted from 4 9's so that the difference is exactly divisible by 16. Okay, we need to subtract it from 4 9's so that our output, the resultant will be exactly divisible by 16. That is the question they asked us. So what you need to do, first of all, divide 4 9's with 16. Okay, right, 4 9's, 4, okay, I will go with 16 6 are 96. I will be left with 3 and 9 will come here. 16 2's are 32, 7 and 9. Okay, next 16 4's are what I will get here? 64. and what is the remainder I have here? 15. 15. What is meant by this remainder? This remainder is nothing but after multiplying 16 with 624, there will be some more excess value. That excess value is nothing but the remainder for us here. So now tell me what is the value I need to subtract from 4 nines so that the reference, that means the output is exactly divisible by 16 means nothing but 15. Is nothing but 15. When you subtract 15 from 4 nines, 15 from 4 nines, okay, when I subtract 15 from 4 nines, what happens to this? 9984. So 9984 is exactly divisible by 16. Sorry, yes, 16. So I need to subtract here 15 from the given number, right? Next one. 3 bells ring at an interval of 15, 30 and 45 minutes respectively. At what time will they ring together? If they rang simultaneously at 8 a.m. There are 3 bells for us. See here students, this process is nothing but the LCM process, which we have seen in our previous session also. Now see here, actually for every 15 minutes it will ring, right? So it will ring at 15, for example. All the 3 are simultaneously rang at 8 a.m. right? So next it will ring at 8:15. Next it will ring at 8:30. Next it is going to ring at 8:45. Next at 9 o'clock. Like this, the first bell will ring. When it comes to my second bell, it will ring once again after 8:30. Next after 9 o'clock. Next 9:30. And so on. Like this, the second bell will ring. Next, when it comes to my third bell, it will ring at 8:45. Next it will ring at 9:30. Next it will ring at 10:15. Like this. The pattern will continue. The pattern will continue. So this process is nothing but finding the LCM. Simply find the LCM of the numbers. That is enough. We can easily solve the answer. Okay? We can easily solve the answer. Right. So find the LCM. What is the LCM which we get here? Please observe and find the LCM. The LCM of 15, 30 and 45. LCM of 15, 30 and 45 we need to find. So LCM of 15, 30 and 45. See, there is one of the basic method and the other simple and shortcut method is go with the multiples of 45. See, what is the, anyway, 15 is a factor of 45, right? So no need to worry about 15. Simply check the LCM of 30 and 45. Whatever the answer you get there, that is enough. So if you go with the multiples of 45, what you get? 45 ones, is 45 divisible by 30? No. 45 twos is 90? Yes, 90 is divisible by 30, right? So the LCM of these three numbers will become obviously 90 for us here. Okay, now simply after 90 minutes, once again all the 3 will ring simultaneously. After 90 minutes. So 8 o'clock plus 8 a.m. plus 90 minutes means what? It is nothing but 9:30 a.m. That means at 9:30 a.m. once again all the 3 bells will ring simultaneously. This is one of the most commonly asked questions, students. When they ring simultaneously or something like this, they will also say what we can say traffic signals. They may use the word traffic signals or an event or something like this. So this is one of the most commonly asked questions. So keep an eye on this. Next one. Find the LCM of a b square c square, a square b c and a cube b cube c square. This is one of the common questions, but for your understanding we will write a b square c square, a square b c and a cube b cube c square. Anyway, each and every term contains all the 3 variables, right? A, B, C. So our LCM also obviously contains A, B and C. Now after writing this, take the highest power. Take the highest power of A among the given numbers. What is the highest power of A among the given numbers? Cube. So cube. Next, similarly, B's highest power is also cube. So this also becomes cube. Next, C's highest power is square. So it will become square. Please be careful. For C here they didn't given us cubic root on cube. Only C square is the highest one. So directly we are going to take the LCM. For example, for the same question, if they asked us what is the HCF, then what we will do is we will take the variables which are only common. See, for example, continuity to this, if I take one more term something like D, I need to find the LCM of this one also. But actually D is not there in this, right? But still I need to take D also into consideration and I need to write my LCM as D to the power of 1. Anyway, D was there for only one time and its power is also 1. So I will directly take it as D to the power of 1. That is fine. Okay. So irrespective of the number, whether it is there in all the terms or not, we can take that value. But when it comes to HCF, for example, if I want to find the HCF for the same data, see students, later we will see about this D. But for example, for the same question, if I want to find the HCF, what I am going to do here is, see here, right, what are the common terms which we have here? A, B and C, right? A, B and C was there in all the three. Okay, good, superb. So HCF, A, B and C. Now in this case, take the least power. Least power. What is the least power of A? I have here 1. So A to the power of 1. What is the least power of B? I have here 1. I have taken B to the power of 1. What is the least power of C? I have here 1. So my HCF here becomes A, B, C. For example, for the same thing, if I have one more term D here. So what happens to my HCF here? Here the HCF is 1. The reason is very simple. Why? Because here all the terms doesn't have a common term. All the numbers doesn't have a common term. Here I have ABC, here I have ABC, here I have ABC. But I don't have ABC in this fourth one, right? And at the same time, here I have D, but I don't have D's in this 2, in this 3. So my HCF will become 1. So in case of HCF, you will write only the common terms and take the least power. In case of LCM, you will write all the terms and you take the highest power. Why I am telling this one means, later you may have questions based based on ABC. You may see questions based something like this. 2 cube into 5 square, into 3 to the power of 4, something like this. They will give you the cases. In that cases, you can use this concept, right? Next. Two numbers are in the ratio 3:4. Their LCM is 84. The greatest number is. Just now I have told you, if two numbers are in the ratio 3:4 means what you are going to take them as? 3x and 4x. You are going to take two numbers as 3x and 4x, where x is our HCF. Okay, good. We know that product of two numbers is equal to product of their LCM and HCF. So 3x into 4x is equal to 84 into x. X and x will get cancelled. 4 ones, 4 21s, and 3 ones, 3 7s. So x value will become what first here? 7. That is nothing but the HCF. Okay. Now they are asking us the greatest number is. What is the greatest number among these two? 4x. 4x means 4 into 7, that is 28. So 28 is the greatest number for us among the given two numbers. Next. LCM of two numbers is 120 and their HCF is 10. Which of the following can be the sum of those numbers? Now see here students, given that LCM is 120 and the HCF is 10, and they are asking us which of the following can be the sum of the two numbers. We know that product of two numbers is equal to product of their LCM and HCF. Okay, that means what you can take? 120 into 10, that is equal to A into B. Okay, good, superb. Now see here students, the two numbers A and B will be definitely multiples of 10, right? Why? Because their HCF is 10. So the two numbers will be definitely a multiple of 10. So it may be some 10x and 10y. The two numbers can be multiples of 10, right? Very common. Why? Because their HCF is 10. Obviously the two numbers will be multiples of 10. Okay, assume. Okay, for your better understanding, I will take the two numbers are in the ratio of x is to y. Then what about those two numbers? I can take those two numbers as 10x and 10y, right? The reason is their HCF is 10 they given for us in the question itself. So I will substitute the same thing here. So what happens to this? 10x into 10y is equal to 120 into 10. Right? Product of two numbers is equal to product of their LCM and HCF. So 0, 0, 0, 0 get cancelled. So xy is equal to what I will get? 12. Xy is equal to what I get? 12. And we also know that the numbers in the ratios will be always what? Co-primes. The numbers in the ratios will be always co-primes. Now tell me, which two numbers product of two numbers should be 12 and those two numbers should be co-primes. Tell me how many pairs I can write? 1 and 12 is one pair. Good. Next pair is 3 and 4 is 1 pair, 3 4s are 12, 3 and 4 are co-primes, 1 and 12 are co-primes, 1 12 is 12. And next when it comes to 6 2s, actually 6 2s is 12, but is 6 and 2 are co-primes? No, 6 and 2 are not co-primes, so we are not going to take them as our pairs here, right? Only these are the possibilities which we have. To get two numbers product as 12 is 1 and 12, 3 and 4. We can also write 6 and 2, but we are not going to consider 6 and 2. The reason is 6 and 2 are not co-primes. Okay, if you want to know about co-primes and everything, go to our previous sessions. There we discussed in detail about those co-primes and all the remaining things. So what are the chances I can have? 1, 12 and 3 and 4. So if I take 1 and 12, what will be our answers? One will be 10 and the other one will be 120, sorry. And if you take 3 and 4, our two numbers will become what? 30 and 40. Why? Because 10x and 10y, right? So 10 plus 120 it is 130. Do we have 130 in the options? No. 30 plus 40, what it is? 70. We have 70 in the options, so our answer is here 70. See, there is chance for both these pairs. Okay, actually here we have two chances, but in the options given for us, we have only one option which is 70. So we are going with that 70. Next, product of two co-prime numbers is 117, their LCM is. Now, product of two co-prime numbers. Now tell me what will be their HCF? HCF will be always 1. Am I correct or not? HCF of two co-primes will be what? HCF of two co-primes will be always 1. HCF of two co-primes will be always 1. So, we will take the same thing. Product of two numbers is, two co-prime numbers is 117 is equal to product of their LCM and HCF. So, LCM into 1. Why? Because their HCF is obviously 1. That is equal to 117. So, what happens to our LCM here? 117. Our LCM will be 117. Okay, if you know the concept, it becomes very easy for us to solve the problems. If not, it takes some time. Next one. The LCM of two numbers is 4 times their HCF. Okay. The sum of LCM and HCF is 125. If one of the numbers is 100, then the other number is. They are telling that LCM of the two numbers is 4 times the HCF. Right. So, what we can take, if HCF is X, we have done the similar problem earlier also. What happens to our LCM? It becomes 4x. And they are telling that the sum of these two is 125. That means x plus 4x is equal to 125. 5x value becomes 125 and our x here becomes 25. If x is 25, that means HCF is 25 and LCM becomes 100. Why? Because LCM is 4x, right? So, HCF is 25 for us here. When it comes to LCM, it becomes what? 100. LCM is 100 for us. Okay, good, superb. Next, if one of the numbers is 100, then the other numbers is. We know that product of two numbers is equal to product of their LCM and HCF. We are going to apply the same thing. 100 into 25 is equal to, one number is 100 and the second number we don't know, assume it as A. 100 will get cancelled. The second number will become what? 25. Here the second number is 25 for us. Okay. Next. The product of two numbers is 2160 and their HCF is 12. The number of such possible pairs is, okay, given that HCF is 12, right? So, if I assume that two numbers are in the ratio of x is to y, if the two numbers are in the ratio x is to y, then what happens to those two numbers? And given that HCF is 12, right? So, two numbers becomes what for me now? 12x and 12y. Okay, the two numbers will become for me 12x and 12y. And they are saying that the product of two numbers is 2160. So, that means 12x into 12y is equal to 2160. Right? So, now 12 ones is 12, I will be left with 96, 8 and 0. Right? Next, 12 ones, 12, 15s. So, at last what I got here, xy is equal to 15. Xy is equal to 15. And we already know that the numbers in the ratios will be always co-primes. Co-primes. The reason is when you write anything in the form of ratio means we cannot further cancel them, right? Up to that form we will cancel and we will write, right? See here students, if you have 40 and 20, will you cancel only with the two table? and write your answer as 20:10, or you will further cancel it? Definitely you will further cancel it, and up to what you will cancel it? Up to the position of 2:1. You cannot leave it in the middle, right? So now you cannot further cancel them, means there will be no common factor between them except 1. So up to that instance we need to cancel the ratios, right? So the same concept here. If you are writing two numbers in the form of ratio, means obviously those two numbers will be what? Co-primes. Co-primes. X and Y are co-primes here. So now tell me, which co-prime pair's product is 15? See, usually how we can get? How 15 will be get? Think for us, 15 ones is 15. And the other one is what? 3 5s. 3 5s is also 15. Apart from this, do we have any other choices? No, we don't have any other choice. So here 15 and 1 are co-primes, 3 and 5 are also co-primes. Now tell me how many pairs of such numbers are possible. That means that product of two numbers are possible. So how many pairs are possible for us? 15 and 1 is one pair, 3 and 5 is the other pair. So total 2 pairs are possible for us. 2 pairs are possible for us. Next one. What will be the least number which when doubled will be exactly divisible by 12, 18, 21 and 30. Now there is a number which is doubled and then that number will be divisible by 12, 18, 21 and 30. Now tell me which number will be divisible by 12, 18, 21 and 30? Nothing but the LCM of 12, 18, 21 and 30. Simply find the LCM of those numbers. LCM of 12, 18, 21 and 30. Okay. Simply find the LCM. Go with the basic only. No need to worry or think too much about all these things. Small things. Go with the basics. We know 3 4s, 3 6, 3 7s and 3 10s. Next 2 2s, 2 3s, 7s and 5s. We are left with only prime numbers, right? So 3 2s are 6, 6 2s are 12, 12 3s are 36, 36 7s. Or else 36 5s is 180, 180 7s, 18 7s are what you will get? 126. So 1260 is the number. But what is the question? Did they ask us the LCM? No. There is a number x. When it is doubled, that means it should be doubled means nothing but 2x. Then that number is divisible by all these three numbers. That means 2x is equal to here 1260. Actually 1260 is the number which is exactly divisible by these numbers. But what they are telling, there is a number which when doubled then it will be divisible. That means what I can write, 2x is equal to 1260. So what happens to my x in this case? 630. X value becomes 630. So please be careful. Why? Because in the options they are also given us 1260. In the options they are also given us 1260. So there is a chance of getting confused. Actually there is a number which should be doubled. So x is that number. When I double it, it should be equal to 1260. So our answer here is 630. Please be careful. Right? With this, almost all the different models of questions from our LCM and HCF was finished. In our next sessions, we will see a new topic. Right? Thank you.